Hi, I'm going to talk about sparse distributed representation and CLA. These two terms you may not have understood previously from my previous uh, video. So this is a supporting video. A sparse distributed representation SDR is this. First, I will tell you how different it is from a normal binary code. Let's say this is an ASCII code, so it represents something. Now if you now if you make this on bit as 0, then the whole ASCII code changes, right? In the same case, if you make one of the on bits in this SDR 0, nothing changes. So basically SDR is sparse, so the on bits are very sparsely distributed, like our brain. There are like million neurons, only 2% or 0.2% of them are on at a time. Only like 100 neurons will represent a pattern, but there are million neurons. Same, okay, it's distributed, which means that it is distributed. And yeah, so one bit doesn't mean anything. A group of bit means something. A group of bit forms a pattern, and that pattern symbolizes something. If you just go for one bit, like this one bit, this this on bit can be a part of this pattern. It can be part of 10 different patterns. It may be on for 10 different patterns, so it doesn't represent some anything significant, but the whole group of on bits represent one pattern. So this makes it fault tolerant. Now the CLA is, okay, suppose we have two letters H and I. First comes the letter H, then comes the letter I, and it represents a word hi. So this is the sparse distributed representation for H. This one is for I. This is the memory matrix which represents the sequence of letters, and this is the higher SDR which represents a word. So let's start with the letter H. So it's represented with first on bit, then fifth on bit, sixth on bit, other bits 0. Okay, now it's represented in this memory matrix like this, like first row of that, this on column, the columns are same, see, the columns are same, only the number of rows have changed. Suppose we have a letter I after H, so last three bits are on, so you see there's a pattern over here, like last three columns, first row, second row, third row. Now if the letter I was followed by like a letter A was before I, like it, suppose the word was AI and not HI, then the columns would have been same, but the rows would have been different. Like last three columns would have the one bit, but the row, like this one won't be here, maybe it would be here, because it was preceded not by H but by A. Okay, and then all these on bits together contribute. They form a connection up here to form a higher level SDR matrix. Thank you.